So we are looking for a first degree polynomial that will match or approximate this function when x is equal to 4. So this is centered at 4, and that's going to be exactly equal to our function f, and again when x is equal to 4. So here's our polynomial when x is 4, and there's our function when x is 4, and we force them to be equal to each other. This is 0, so a naught is 4 divided by 2, or 2. Alright, now we need to find the coefficient a sub 1. And we'll do that by forcing the first derivatives to be equal to each other, again when x is 4. So the derivative of p, this is a constant, its derivative is 0, and the derivative of this term is just a sub 1. And the derivative of 4 over the square root of x is negative 2x to the negative 3 halves. We'll force the first derivatives to be equal to each other when x is equal to 4, which is where it's centered. So on the left side, when x is 4, that expression is just a sub 1. And on the right side, when x is 4, we have negative 2 times 4 to the positive 3 halves on the bottom. That's the square root of 64, which is 8. So negative 2 over 8 is negative a quarter. And that does it. We're looking for a polynomial. And for the polynomial, its DNA is all contained within the coefficients. So if you find those coefficients, you're done. So our first degree polynomial is 2 minus a quarter of x minus 4. And the graph they asked for is right there.